Oh, hi, I'm Kay Batwell. You caught me relaxing in my project lounge. The 555 timer IC has been in production since 1972. That's almost 50 years of this being produced. Some estimate that maybe 1 billion of these are made every year. And if that's the case, going all the way back from the beginning, there are 7 555 timers for every person on the planet. In this project, we're going to use a single 555 timer to make a multi-button synthesizer that plays accurate whole notes. So let's get started.
But first, complete silence as we wait for the maestro to play his masterpiece. Well, here it is, the complete circuit. Go ahead, build it, and thanks for watching. Just kidding. But it does look good. Let's take a look at the circuit. This is the complete circuit. As you can see at the top left, in the upper left corner, you could technically add as many buttons as you wish. Add too many, and you have to take into account the resistance of the wire as the keyboard gets longer and longer. Let me simplify what's happening in this circuit. This is a block diagram of what's happening in there. The frequency at the output, that's the sound that you'll hear, is determined by the resistor R1, R2, and capacitor C1 on the left side there. This configuration is known as a stable oscillator, A-stable multivibrator, or just A-stable mode. In A-stable mode, pin 6 and pin 2 are connected, and that causes the circuit to re-trigger itself, creating the output frequency. Capacitor C1 is charged through R1 and R2, and then discharges through R2 into pin 7. The ratio between R1 and R2 determines that frequency. So let's look back at the original circuit. Where is R1, R2, and C1? Right here. So I made R1 and C1 a constant. So that means that R2 is the only variable that's going to change, and this is how we determine the frequency at the output. R2 is the first one. R3 is the next note in the piano, going a little deeper in tone, and that's added to the first note. So both resistors are added for R3. Go down to R9, and it's all the resistors from R2 to R9 added together to create the final note. How exactly is the frequency calculated? Right here. The frequency is the musical note we're looking for. Since we already know R1 and C1, and technically we know the frequency also, we have to rearrange the equation to figure out what R2 is supposed to be. Here it is. I already worked out R2 for the musical note C6, which is a frequency of 1046.5. I need an R2 of 6188.96 ohms. The closest single resistor I could find to that size is 6.19 k ohms. Plug that back into the original frequency equation just to check to see, and the frequency comes out to be 1046.34, which is very close to the 1046.5 hertz that I needed for the note C6. I went back in and did that for the rest of the resistors, and I came up with this table of resistor values. If you're feeling ambitious, you could use precision resistors and multiple resistors for each stage, for each note, and get a value closer to the actual frequency needed. Resistor value is added to the last one as it builds all the way down to the note C5. Using a 555 timer can seem intimidating, but it's not.
Okay, what's happening here is, in the first note, only this one resistor, the first one right here, is being used to create the frequency. On the second note, you're adding up this resistor, and it goes through this button and completes the circuit. So it's a little bit lower. And so on. You keep adding all of these resistors together until you get to the last one. Like a regular piano, I go from low notes to high notes.
Now that you know why it works and how it's designed, now it's time to build it on an actual breadboard. Here is a picture of it in its final form. I put together a step-by-step breadboard build for you to follow, so you can stop anywhere in the frame and check your work or just follow along with the video itself. This is the final breadboard shot. If you're curious what switch 2 does, I put that there so you can, as you switch back and forth, you send the output signal through either a capacitor or a resistor to modify the sound. Add whatever you want there to play with the tones or the sound. I always did wonder what a low pass or high pass filter would do right there. I don't know.
Until next time, I'm Kay Batwell. I'll play us out.
I thought you were.
I wish. Remy, here's the problem with doing project videos. I have to do so many.
Okay, Remy,
What?